Fresh observations are now shedding new light on 3I-ATLAS, the massive interstellar visitor that's been puzzling astronomers since its discovery. What started as excitement over finding our third interstellar object has transformed into something far more intriguing and honestly controversial. Recent data analysis reveals patterns that just shouldn't exist in natural objects. Orbital characteristics so precise they seem almost intentional. Professor Avi Loeb and other researchers are asking uncomfortable questions. What if 3I-ATLAS isn't just a comet? What if it's something designed to study us while appearing completely natural? Fresh observations reveal mysteries. Recent months of intensive observation have transformed 3I-ATLAS from an exciting discovery into astronomy's most controversial object since Oumuamua. Dr. Robert Warwick from the University of Hawaii, who led the discovery team, admits that new data has revealed characteristics that challenge our understanding of natural interstellar objects. The object's behavior patterns have proven increasingly difficult to explain through conventional comet models. Advanced spectroscopic analysis by the European Southern Observatory shows surface composition anomalies that don't match any known class of solar system bodies. Most puzzling is the object's thermal signature, or rather the lack thereof. Despite approaching within 0.7 AU of the Sun, 3I-ATLAS shows minimal heat emission and no detectable outgassing. Dr. Michelle Bannister from the University of Canterbury noted that objects this size should be streaming gas and dust as they heat up, but we're seeing virtually nothing. The observations have split the astronomical community between those who believe there must be a natural explanation, and others who are beginning to consider more exotic possibilities. NASA's Deep Space Network continues tracking the object, but each new measurement seems to deepen rather than resolve the mystery. The scientific debate. The astronomical community finds itself divided over 3I-ATLAS, with heated debates emerging at conferences and in scientific journals. Dr. Alan Fitzsimmons from Queen's University Belfast leads the conventional camp, arguing that extraordinary claims require extraordinary evidence, and we haven't reached that threshold yet. His team maintains that unusual properties can be explained by exotic but natural compositions, possibly involving nitrogen ice or other materials rare in our solar system. However, a growing faction of researchers questions this dismissive approach. Dr. Daryl Seligman from the University of Chicago, who previously proposed natural explanations for Oumuamua, admits that 3I-ATLAS presents characteristics that are harder to reconcile with known natural processes. The debate intensified when thermal modeling by Dr. Marco Michelli from the European Space Agency revealed that the object's temperature distribution doesn't match any known natural body. Spectroscopic measurements show absorption lines that appear artificially narrow, suggesting either unknown physics or manufactured materials. Dr. Sarah Seeger from MIT cautioned against rushing to conclusions, but acknowledged that we may need to expand our definitions of what constitutes natural phenomena in interstellar space. The scientific method demands skepticism, yet the mounting anomalies are forcing astronomers to confront uncomfortable possibilities. The artificial origin hypothesis. Professor Abraham Loeb, former chair of Harvard's astronomy department, has emerged as the most vocal proponent of an artificial origin for 3I-ATLAS. Building on his controversial Oumuamua research, Loeb argues that the object displays technological signatures that suggest intelligent design rather than natural formation. His analysis focuses on the object's perfect orbital mechanics, unusual surface properties, and lack of expected comet behavior. Loeb's calculations suggest that 3I-ATLAS's trajectory shows statistical precision that would be virtually impossible to achieve naturally. The object's approach vector, timing, and encounters with multiple planets create what he calls a reconnaissance pattern consistent with systematic exploration. In his recent paper submitted to Astrophysical Journal Letters, Loeb proposes that 3I-ATLAS could be a probe designed to study our solar system while maintaining the appearance of a natural comet. His hypothesis suggests that advanced civilizations might use such camouflaged objects to observe other star systems without detection. Critics argue that Loeb is making extraordinary leaps from limited data, but his mathematical analysis of the object's properties continues to gain attention from researchers who find conventional explanations increasingly inadequate for the mounting anomalies. Unusual detection pattern. The circumstances surrounding 3I-ATLAS's discovery reveal troubling patterns that suggest possible stealth capabilities. Dr. Larry Deneau from the Atlas Asteroid Survey noted that the object should have been detected 18 months earlier based on its size and trajectory, yet it remained invisible to all automated survey systems until July 2025. The delayed detection becomes even more suspicious when considering the object's approach vector from the constellation Lynx, a region of sky that multiple survey telescopes regularly monitor. Orbital reconstruction by Dr. Davide Farnochia at NASA's Jet Propulsion Laboratory reveals that 3I-ATLAS entered the outer solar system in January 2024, but somehow avoided detection despite passing through well-monitored space. The object's approach direction created additional observational challenges, as it remained positioned in areas of sky that were difficult to observe from Earth-based telescopes for extended periods. Dr. Catalina Donovan from the Linear program admitted that objects this bright should have triggered multiple detection systems, but somehow it remained hidden until practically on top of us. This pattern of avoiding detection until the last possible moment really raises questions about whether the concealment was accidental or intentional, adding weight to theories about possible artificial intelligence guiding the object's approach. Suspicious orbital characteristics. 3I-ATLAS's orbital mechanics present statistical anomalies that challenge natural origin theories through their mathematical precision. Dr. Fatih Namouni from Côte d'Azur Observatory calculated that the object's perfect alignment with the ecliptic plane has only a 0.2% probability of occurring naturally for an interstellar visitor. More striking are the object's sequential close encounters with Venus, Mars, and Jupiter, which orbital dynamicist Dr. Mattia Galeazzo from the University of Vienna determined has only a 0.005% probability of happening by chance. The precision of these encounters suggests either extraordinary coincidence or deliberate trajectory planning. 3I-ATLAS will pass within optimal observation range of each planet, maximizing potential data collection opportunities about their atmospheric compositions, magnetic fields, and moons. Dr. Alessandro Morbidelli from the Observatory of the Côte d'Azur noted that the trajectory looks almost designed to provide comprehensive reconnaissance of our solar system's major worlds. The object's velocity profile also shows subtle variations that correlate with planetary encounters, suggesting possible course corrections that natural objects shouldn't exhibit. Statistical analysis by Dr. Renu Malhotra from the University of Arizona concluded that the combined probability of all observed orbital characteristics occurring naturally is less than 0.001%, forcing serious consideration of artificial guidance systems. The hidden approach strategy. 3I-ATLAS's approach timing demonstrates what researchers are calling strategic concealment that maximizes the object's ability to study Earth while minimizing detection opportunities. Dr. Paul Wiegert from Western University discovered that the object's perihelion passage in December 2025 coincides with Earth's position in its orbit, creating an observational blind spot that has a 7% probability of occurring randomly. During this critical period, 3I-ATLAS will be positioned directly behind the Sun from Earth's perspective, making detailed observation extremely difficult while allowing the object unobstructed views of our planet. Celestial mechanics expert Dr. Kleomenis Tsiganis from Aristotle University noted that this timing allows the object to study Earth's electromagnetic emissions, atmospheric composition, and artificial satellite networks without interference from ground-based observations. The approach strategy becomes more sophisticated when considering that 3I-ATLAS will emerge from behind the Sun in January 2026 at optimal angles for both radio telescope detection and deep space communication. Dr. Seth Shostak from the SETI Institute acknowledged that if we were designing a reconnaissance mission to study an inhabited planet, this trajectory would be nearly optimal. The implications are unsettling. 3I-ATLAS appears positioned to conduct comprehensive Earth observation while maintaining plausible deniability as a natural comet. Scientific opposition and evidence. Despite mounting anomalies, many astronomers maintain strong skepticism about artificial origin theories for 3I-ATLAS. Dr. Alan Harris from the German Aerospace Center argues that size estimates remain uncertain, and unusual properties don't automatically imply artificial construction. His team's thermal modeling suggests the object could be significantly smaller than initial estimates, potentially explaining some observed anomalies through natural processes. Dr. Vishnu Reddy from the University of Arizona emphasizes that interstellar objects should be expected to show unusual properties, since they formed in different stellar environments with unknown conditions. Counter evidence includes spectroscopic data showing absorption features consistent with water ice and rocky materials, though critics note these signatures could be engineered camouflage. Dr. Julie Castillo-Roges from NASA's Jet Propulsion Laboratory points out that we've only studied 3 interstellar objects, making it premature to define what constitutes normal behavior. The scientific opposition maintains that natural explanations involving exotic ices, unusual mineral compositions, or unknown formation mechanisms remain more plausible than extraterrestrial technology. Dr. Bonnie Barati from JPL advocates for continued observation rather than speculation, arguing that patience and data collection will eventually reveal natural explanations for these apparent anomalies. However, each new observation seems to strengthen rather than weaken the case for artificial origins. Ancient origins and anomalous behavior. Age analysis of 3I-ATLAS reveals characteristics that seem to defy the natural aging process expected for interstellar objects. Dr. Grigory Fedorets from Queen's University Belfast estimates the object's age at over 7 billion years based on surface composition analysis, making it older than our solar system yet showing no signs of expected cosmic weathering. Objects drifting through interstellar space for such periods should exhibit significant cosmic ray damage, micrometeorite scarring and surface oxidation, yet 3I-ATLAS appears remarkably pristine. Most puzzling is the complete absence of a comet tail despite the object's approach to within 0.7 astronomical units of the Sun. Dr. Matthew Knight from the University of Maryland noted that any object containing even trace amounts of volatiles should be outgassing visibly by now, but we're seeing nothing. Structural analysis by Dr. Jean-Baptiste Vincent from the German Aerospace Center reveals density variations that are inconsistent with typical water ice spectra, suggesting either unknown materials or artificial construction. The object's rotation period of exactly 12 hours also raises suspicions, as natural bodies typically show irregular rotation rates due to impact history and gravitational perturbations. These ancient origins combined with anomalous behavior patterns continue to challenge conventional explanations. The stealth hypothesis. The concept of deliberate concealment has emerged as a serious consideration among researchers studying 3I-ATLAS, potentially related to dark forest theory implications for interstellar civilizations. Dr. Liu Cixin's theoretical framework, popularized in science fiction but based on real game theory, suggests that advanced civilizations might prefer stealth over open contact to avoid potential threats. Professor Avi Loeb proposes that 3I-ATLAS represents what he calls archaeological reconnaissance, a method for studying planetary systems while maintaining the cover of natural phenomena. This hypothesis explains why the object exhibits just enough anomalous behavior to suggest artificiality to careful observers while maintaining plausible deniability as a natural comet. Dr. Jacob Haq Misra from the Blue Marble Space Institute has studied the implications of such stealth strategies, noting that advanced civilizations might prefer observation over contact to minimize risks while gathering intelligence about other worlds. The stealth hypothesis suggests that 3I-ATLAS could be collecting data about Earth's technological level, atmospheric composition, and artificial electromagnetic signatures while appearing to be a routine interstellar visitor. Radio telescope monitoring by Dr. Sophia Sheikh at the SETI Institute has detected no obvious artificial signals, but sophisticated probes might use communication methods undetectable by current technology or transmit data during periods when Earth-based observations are impossible. Lessons from Oumuamua. The scientific community's handling of Oumuamua in 2017 provides crucial context for evaluating 3I-ATLAS and the importance of maintaining open-minded investigation. Dr. Robert Warwick, who discovered both objects, admits that we missed significant opportunities with Oumuamua by dismissing anomalies too quickly rather than pursuing thorough investigation. The 2017 visitor exhibited unexplained acceleration, unusual reflectivity, and extreme elongation that were initially attributed to natural causes without adequate investigation. Professor Abraham Loeb's controversial artificial origin hypothesis for Oumuamua was largely dismissed by the astronomical establishment, yet alternative natural explanations have proven increasingly problematic under scrutiny. Dr. Daryl Seligman's hydrogen iceberg theory requires formation conditions so exotic they approach the implausible, highlighting the difficulty of finding natural explanations for truly anomalous objects. 3I-ATLAS represents a second chance to properly investigate an interstellar visitor with advanced instruments and sufficient observation time. Dr. Thomas Zurbuchen, former NASA Associate Administrator, emphasized that extraordinary phenomena deserve extraordinary investigation, not extraordinary dismissal. The lesson from Oumuamua is clear. When faced with genuinely anomalous objects, the scientific community must resist the temptation to force natural explanations and instead pursue comprehensive investigation that considers all possibilities, including those that challenge our current understanding of what's possible in the universe. 3I-ATLAS continues its journey through our solar system, carrying secrets that may fundamentally challenge our understanding of what travels between the stars. Whether it's an exotic natural phenomenon or something more extraordinary, this mysterious visitor has already forced astronomers to confront uncomfortable questions about the universe around us. The patterns are too precise, the timing too convenient, and the behavior too strange to dismiss easily. Subscribe to Stellar Tech for more investigations into cosmic mysteries that blur the line between natural phenomena and something far more intriguing.